All right, lesson 3.2, your favorite math topic ever, factoring. We've already been practicing a little bit of factoring this year here and there, but today we're going to really jump in with both feet. So first of all, factoring is just unmultiplying polynomials. It's like a mystery game where you start with a polynomial and you try to figure out what polynomials could be multiplied to give you that result. So like what I have on the screen, the 4x times the x plus 7, if I wanted to multiply that, I just would, of course, distribute the 4x to each of those terms, which would give me this as a result. Well, when I'm factoring, I'm starting with a result, a polynomial like this, and I'm trying to think about what two things could be multiplied together to give me that result. In this case, the two things that multiply to give me 4x squared plus 28x are a 4x and an x plus 7. So that's what we're doing today, is we're just sort of solving this mystery of what things multiply together to give me this polynomial. For today, just FYI, we are just focusing on factoring expressions. We will not have any equations with equal signs today. Your answer will not be x equals this number. We are just working on trying to find the factors or the things that multiply together to give us a polynomial. So the first thing we want to think about when we are factoring is there a common factor among my terms? For example, when I'm looking at that first polynomial, 18 minus 9x, I have to ask myself, do these two terms have anything in common? And we want to find the greatest common factor. We want to find the term that they have in common that is absolutely the biggest possible factor that they have in common. Well, 18 and a negative 9x have a factor of 9 in common. And if I think about what would 9 be multiplied by to give me an 18 minus a 9x, well, to get 18 in that first term, I would need to multiply by 2. And to get a negative 9x in that second term, I would need a negative x. So whenever you're factoring, if you're not sure if you were correct or not, think about multiplying it out. Sometimes you can multiply it out in your head without writing anything, but that would give me the 18, and this would give me a negative 9x. So you can check yourself to figure out if you factored it correctly or not. So this second polynomial here is a trinomial, and the first thing again that we want to think about is there something that these terms all have in common? And you might notice, first of all, that those are all even coefficients, so we definitely have a 2 in common, but also every single term here has at least one factor of x. When you're looking for common factors, you're thinking about numbers, but you are also thinking about variables. So the common factor here is 2x, and if I factor that out, I have to think about what I would need in each of these three spots to give me this result. So in this first term, negative 2x to the third, well, what would I need here to multiply to give me that 2x to the third if I'm multiplying by 2x? Well, I would need an x squared. So if I multiplied that 2x by the x squared, that gives me the 2x to the third. So now let's think about our next term. Our next term, let's see, is a 24x squared. So I need to know, what do I need here so that if I multiplied it, I would get a 24x squared. Well, to get a 24, I need a 12. And to get x squared, I would need an x. Whoops. Let's see. Yeah, let me get rid of that for a minute. And for our last term, right here, we have a negative 26x, so I already put my minus sign here. Again, we're thinking about what would I multiply by here with that 2x to get a negative 26x? Well, that would be a 13, and I don't need an x with the 13 because the x is with the 2, and I just want one of those to get 26x. So my factorization, if I factor out that 2x, looks like this. Now, you might be thinking to yourself, can I factor that part of it? And the answer is yes. So let's talk about how to factor that part of it. Not that one in particular, but we're going to factor that type now. So these two, we just looked for a common factor. You should always look for a common factor. But now let's focus on trinomials like this, where either there's not a common factor or that common factor has already been factored out. So if I have a trinomial like x squared plus 9x plus 14, if it's factorable, it came from two binomials like this. Now the first term x squared, it came from multiplying these two together. So as I'm thinking about how to factor, I can focus on this to give me the first term in the binomials. And these two multiply together to give me that last term. So when I'm thinking about those two spots, I'm really focusing on this number 14. The tricky part with factoring is that this middle term 9x, it's made up of two parts. It's made up of these two things. In this case, it's a 2x and a 7x. So we have to do a little bit of investigative work or a little bit of guessing and checking to try to come up with the right combination of numbers. Now again, we are only factoring expressions today. We aren't going to have any equal signs. Our answers are not going to look like x equals today. We'll work on solving next time. So I want to start by factoring this. So I'm trying to think of what two things would multiply together to give me, sorry, one little space, to give me x squared plus 4x minus 32. Well, remember these two multiply together to give me this term. So it has to be an x times an x. It's just an x squared there, so that's definitely x times x. Well, for the other side, for the constant terms, we have a couple of possibilities. 32 is the same as 1 times 32. It's the same as 2 times 16. It's the same as 4 times 8. And at first, it might not be clear to you which of those to check. And it's absolutely okay if you can't immediately see which one to check. The more you practice factoring, the better you will get at picking out the right combination quickly. But maybe, for example, maybe I'm thinking 2 and 16 might work. Well, what you have to do is then just check to see if that gives you the appropriate middle term. This would be a 16x, and this would be a 2x. And there's no way that those can be combined, regardless of how the signs are, into a 4x, because our goal is to create this middle term of 4x. So 16 and 2 did not work. So maybe you try a different combination. Maybe you think it will be the 4 and the 8. Oh, I still have my 16 there. In that case, let's put in the 4 and the 8. So if you thought about what your middle term would end up being, this is a 4x, and this would be an 8x. Well, I can get those two things to add up to 4x if I do an 8x minus a 4x. So if this is negative, that will definitely give me the correct middle term. So I need this to be an x minus 4, and I need this to be an x plus 8. Now you should always check, so I kind of checked the middle. I know that the middle is correct, If you've been playing with the signs a little bit, you might also just want to check that this sign ended up okay. A -4 times an 8 is a -32. So we are good on our signs. And that is the correct factorization. Now, you should always, 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 if you have any hesitation about your factorization, you should, and it's a great idea on a test because it can save you from getting a problem wrong, multiply it out and see if it actually gives you the correct polynomial. So I multiply it out, I combine my middle terms, x squared plus 4x minus 32. It was right. These are the correct factors. Okay, so especially on a test, multiply it out and check yourself. Okay, this one looks really difficult. 4x squared minus 56x plus 180. 180 is a very large number. It would be difficult to come up with all of the different factors or ways of factoring that number. You should always start by asking yourself, do these terms have anything in common? And particularly thinking about that leading term, I would try a 4. If 4 doesn't work, I would try 2 and just test and see. For sure 2 is going to work because those are all even numbers, but if you test out 4, you'll find that 56 is 4 times 14, and 180 is 4 times 45. So you can see every term has a factor of 4 that can be factored out. So if we factor that 4 out, that first term is an x squared. This one, we would be left with 14x. And our last term is going to be plus 45. So factoring out that 4 helps us to see that this polynomial is not too difficult to factor. At least looks a lot more doable. 45 is a little bit easier to think about than 180. 45 could be 1 times 45. It could be 3 times 15. It could be 9 times 5. Those are our combinations for 45. So the GCF, that common factor of 4 that we factored out, it does not disappear. It's still hanging out front. It's not going to go away. Our leading term here is x squared. That tells me that this is going to be an x and an x. And now we're thinking about these combinations here and which one we think is going to work out with a goal of building a middle term of -14. So hopefully, and again, it takes practice. You get better at spotting things the more you practice, but 9 times 5 is going to give us what we want. So if we put a 9 and a 5 in, this would be a 9x, and this would be a 5x. We're trying to build a -14. So if we do both signs negative, that's going to add up. And then I like to check and make sure that my sign is right at the end as well. This is a -9 times a -5, so that is positive 45, just like what we have. So it worked out great. Again, do not lose the 4. It is part of our factorization. The factorization is 4 times x minus 9 times x minus 5. All right, this represents probably one of the most difficult types of polynomials to factor. So it has a 6 coefficient, so you could test, will 6 divide these numbers, or is 6 a common factor? And you'll find that 6 is not a common factor. 29 is not divisible by 6, and 28 is also not divisible by 6. Well, if 6 is your leading term and 6 isn't a common factor, you might try 2 or 3 as a common factor, but in this case, neither of those is a common factor either. So no common factor. I can't factor any common factor out. Well, that means when I think about my two factors that multiply together here, that first term has to be 6x squared. That means we might have a 6x multiplied by an x, or we might have a 3x multiplied by a 2x for our leading terms here and here. So you may just have to try one. Pick one of those combinations to try. I'm going to start with the 3x and the 2x. If I can't find a combination using 3 and 2, I will switch and try 6 and 1. So for the terms here and here, I'm thinking about the number 28. Well, 28 is 1 times 28, 2 times 14, 4 times 7. Those are my combinations for 28. So you literally just have to pick one to try, and sometimes you'll start to develop some good sense of, what's might be the best bet to try first. I am going to try the 4 times the 7 first, but maybe you just randomly throw it in. You put a 7 here and a 4 here. Just pick something and test it. If it doesn't work, you can always switch. This would give me a 14x. This would give me a 12x, which I'm trying to build 29x. So it's close. It would add to 26x, but it's not quite close enough. So if that happens, what you may want to do is just switch those two numbers. I put 7 here and 4 here. Let's switch and put the 4 here and the 7 here and see if that works. So now if I try testing out my middle term, this gives me an 8x and this gives me a 21x. Well, look at that. 8x and 21x adds to be 29x. That's what I was looking for. And in this case, everything just needs to be positive. So I'm going to write my two factors over here. 3x plus 4, 2x plus 7. I'm going to multiply it out and check it and make sure. Again, especially on your test, don't miss a factoring question. Multiply it out and test it. Here is 6x squared. That's a 3x times a 2x. This gives me 21x. Now if I distribute the 4, I have an 8x plus a 28. These two combine, so I get my original polynomial. It worked perfectly. This is the correct factorization. Now, if for some reason when you switched it, you didn't get the correct answer still, you would just try another one of your combinations up at the top. Like if this didn't work, maybe you try the 2 and the 14 next. And you just keep tenaciously going after it until you find the right combination. Okay, 2 more. Almost done. These 2 are tricky because they are binomials. But what is happening, if you look at it, is that it does not have any x's. It's like the ones we've been factoring just barely, but it has a middle term of 0x. So if you have that situation come up, oftentimes these numbers are perfect squares. And those perfect squares, like 4 is 2 squared and 8 is 9 squared, they can help you decide how to split up those numbers. So I'm going to split the 4x squared into a 2x and a 2x. And I'm going to split that 81 as a 9 times 9. Now what you need to get 0x, because this has 0 x's, is that you need one of them to be negative and the other positive. And in that way, it adds up to no x's in your polynomial. So when you have something like 4x squared minus 81, notice or try to start noticing when those numbers are perfect squares. And you can get it to factor like so with a positive and negative sign in the two factors. Okay, let's try one more. Factor 3x to the third minus 147x. Always try to start by just scanning and looking for, do they have something in common? In this case, you may not know what the multiples of 147 are, but because there's a 3 in front of the x to the third, that's telling me that I should at least test 3. And if you test 147, you will find that it is 3 times 49. So that means that our two terms have a common factor of 3, and they also both have a factor of x. So our GCF, or a common factor here, is 3x. Now, if I factor out a 3x from that first term, it's going to leave me with x squared. And from the second term, if I factor out a 3, it's leaving me with a 49. I'm going to factor both the 3 and the x out, so it leaves me with 49. So here is so far what we have. We've factored out a 3x. And now we can continue to try to factor that polynomial into two binomials. Our leading term here is just x squared. And then we have 49 over here. So let's try 7 and 7. So the middle is again a 0x. So if we have a plus 7 and a minus 7, that should work out to give us the 0x that we have in our equation. So this is the perfect factorization. So our final answer, and we don't lose that 3x, it totally stays there. 3x times x plus 7 times x minus 7. So factoring is one of those things that you just have to practice. And the more you practice it, the better that you will get at it. But do your best. Try to factor the ones on the assignment. If you get stuck on some, bring those ones to class and we'll talk about them and some strategies to help you on those ones. So, best math topic ever, factoring. Yay!